Okay, now on to tangent, cotangent. Now, tangent and cotangent you do completely different than secant and cosecant. You don't graph its reciprocal first, you just go straight to its graph. The main thing you need to know about tangent and cotangent is that the formula to find the period is not 2 pi divided by b, but instead it's pi divided by b. The period for tangent cotangent is pi divided by b. So in this one, b is 1. So the period is pi divided by 1, which is pi. The distance between critical points is still the period divided by 4, so the distance between critical points is pi over 4 in this one. Now, I still want you to do your x-axis the same. Go every 4 is pi over 2. And I still want you to go up 2 on the y-axis for 1 and down 2 on the y-axis for -1. Now, because the distance between critical points is pi over 4, I want you to put a slash halfway between 0 and pi over 2. So that's pi over 4. You don't have to label every one. Just make sure you put a slash on the x-axis. And for this first one, I'm going to go ahead and do a table. And because the distance between critical points is pi over 4, I'm going to go up by pi over 4. So I'm going to start with 0. Now think about your unit circle. At 0, the coordinates are 1, 0. Tangent is y over x. So tangent at 0 is 0 over 1, so it's 0. So at 0, 0, you're going to put a point. And I'm going to go ahead and do this in blue because this is the actual graph. Okay? Now I'm going to do pi over 4. Pi over 4 is halfway between. The coordinates at pi over 4 are root 2 over 2, root 2 over 2, tangent's y over x. So the tangent at pi over 4 is 1. So at pi over 4, I want you to put a point at 1. Now at pi over 2, the coordinates are 0, 1. Now at pi over 2, remember it's tangent's y over x. So at pi over 2, it's 1 over 0, so it's undefined. So at pi over 2, you need to put an asymptote, a vertical asymptote. Now I'm going to go backwards. I'm going to go to the left of 0. And this right here is negative pi over 4. Now remember, negative pi over 4 would be in the 4th quadrant, and the coordinates would be root 2 over 2, negative root 2 over 2. So at a negative pi over 4, it's actually negative 1. I'm going to go backwards again, and I'm going to do negative pi over 2. Negative pi over 2 would be here, and the coordinates are 0, negative 1. And remember, tangent is y over x. At negative pi over 2, it's also undefined. So at negative pi over 2, you're also going to do your vertical asymptotes. This is what tangent looks like. You could test points in between, but you'll see that it curves like this and like this. And that is one period. Notice the difference between negative pi over 2 and pi over 2 is pi. That's because the period is pi. And then you just want to copy the pattern. So notice on here, I have asymptotes at negative pi over 2 and pi over 2. They're pi apart. So the next asymptote is going to be at 3 pi over 2. And then to the left, it's going to be at negative 3 pi over 2. Notice how there's a point at 0 halfway between those asymptotes. So there's going to be at 1 at pi. There's going to be 1 at 2 pi, negative 2 pi. And then see how over here you went over 2, up 1. I'm going to do the same thing. And you went over 2, down 2. I'm going to do the same thing. I'm going to do the same thing here. Copy the pattern. And then over here, we're just showing this half. And over here, we're showing this half. Okay, now for cotangent. Cotangent has the same steps as tangent. It just ends up looking a little different because it's defined and undefined in different places. In this one, b is still 1. So therefore, the period, remember the period formula for tangent cotangent is pi divided by b. Yes, so pi divided by 1. So the period for this is pi, and the distance between critical points is still pi over 4. I'm going to go ahead and label my x-axis the same. Every 4, pi over 2. And on the y-axis, go up 2 to make 1, go down 2 to make negative 1. And I'm going to make a table again. I'm going to start with 0. Again, think about your unit circle. At 0, the coordinates are 1, 0. Cotangent is x over y, so it's going to be 1 over 0. So at 0, it's actually undefined. So at 0, you're going to go ahead and draw in a vertical asymptote. Now, because the distance between critical points is pi over 4, that's the next one I'm going to put in. At pi over 4, the coordinates are root 2 over 2, root 2 over 2. Cotangent is x over y, so it's 1. And pi over 4, you guys, is halfway between 0 and pi over 2 right here. So at pi over 4, it's equal to 1. Now I'm going to do pi over 2. Pi over 2, the coordinates are 0, 1. Cotangent is x over y, so it's 0 over 1, so it's 0. Now, halfway between pi over 2 and pi is 3 pi over 4, so that's what I'm next going to plug in. 3 pi over 4 is right here. The coordinates are negative root 2 over 2, positive root 2 over 2. Cotangent is x over y, so it's negative 1. And the last thing I'm going to put in my table is pi. The coordinates of pi are negative 1, 0. Cotangent is x over y, so it's negative 1 over 0, so it's undefined. So that's where the next asymptote is. So cotangent looks like this. And then I'm just going to copy the pattern to cover the whole graph. I'm going to do all my asymptotes pi apart. And then I know there's a point at 0 halfway between each of the asymptotes. And then 2 spaces over, it goes 1, 0, negative 1. Okay, last example. This time we're doing tangent of 2x, and so b is 2. Remember the formula to find the period for tangent and cotangent is pi divided by b. So the period for this is pi over 2. Therefore, the distance between critical points is the period divided by 4. Since it's already a fraction, I'm going to go ahead and multiply it by 1/4. So the distance between critical points is pi over 8. Now, pi over 8 on your graph, this is pi over 2, so this is pi over 4. Pi over 8 is going to be 1 space over. So on this one, I'm going to graph a value at every single space. You don't have to label every single one. Just realize we're going to have a value on every single space. Now, you might have already started to see the pattern on how to graph this, but let me go ahead and use the table just in case. So if I plug in 0, order of operations, you do 2 times 0 first, so it's tangent of 0. And tangent of 0 is 0. So I know there's a point at 0, 0. And that's something you'll learn about tangent. Unless it has a horizontal shift or a vertical shift, it's always going to have a point at 0, 0. And now, if I plug in pi over 8, that's the distance between critical points, realize I have to do 2 times pi over 8. So 2 times pi over 8 actually ends up being pi over 4. So you're really asking, what is the tangent at pi over 4? And remember that it's 1. And then the next thing I want to plug in is pi over 4. Well, you got to plug it in. 2 times pi over 4 is actually pi over 2. And at pi over 2, the coordinates are 0, 1, so it's undefined. So at pi over 4, it has an asymptote. Now, remember that the period is pi over 2. So that means it's going to repeat itself every pi over 2. Well, this is already pi over 4 over. So if you go to the left, I know the next asymptote is going to be at negative pi over 4, which is 2 over. So what you want to do is just copy the pattern. And notice this is negative pi over 4. I know that's going to be at negative 1. You could plug it into your table if you needed to. But that's how small it's going to be. And you're just going to copy the pattern for the entire graph. Notice my asymptotes are 4 spaces apart. So once you see a pattern, you can just keep copying. And there's your graph.